Welcome to the Explainer. Today, we're tracing what I like to call the ultimate hero's journey of the modern software engineer. We're looking at the complete arc of what it really takes to thrive in today's tech landscape. We're going to follow this journey from the very first hurdle, passing that grueling, high-pressure technical interview, all the way to the macro-level triumphs of deploying highly scalable global applications. It's an absolutely fascinating evolution of skills, and we're going to break down exactly what it looks like.
Which brings us to the core question. How do you build the ultimate modern developer? What are the actual components of success in this field today? Well, the answer isn't just about knowing a programming language. It actually requires mastering three distinctly different phases of the software engineering lifecycle. We're talking foundational algorithmic knowledge, AI-assisted coding efficiency, and global cloud deployment.
Okay, let's dive into this. Here is our roadmap. 1. The tech interview crucible. 2. Mastering core data structures. 3. Supercharging with AI. 4. The cloud computing battlefield. And 5. Optimizing cost and performance.
Section 1. The Tech Interview Crucible.
All right, let's start right at the beginning. The very first major trial every aspiring developer faces. Yep, you guessed it. The notoriously difficult data structures and algorithms interview. If you're gunning for a role at tech giants like Amazon, Microsoft, Google, or even dynamic startups like Uber and Netflix, you probably know the exact anxiety I'm talking about. It's practically a rite of passage. This is exactly why mastering foundational concepts and studying resources like cracking the coding interview has become virtually mandatory. You can't just know how to code, you have to understand the underlying logic to solve complex problems under pressure right there on the whiteboard.
Section 2. Mastering core data structures.
To actually conquer that interview, we really need to start at the micro level, with the absolute basic building blocks of all software. Think about arrays, matrices, and vectors. But the array really stands out as the most fundamental data structure, right? It stores elements directly at contiguous memory locations. And interviewers, they absolutely love them because arrays offer incredibly fast O(1) search times, if you know the index, of course. But here's the catch that constantly trips people up. Adding or removing an element is super slow. You literally cannot change the size of an array once it's created. To resize it, you have to create a brand new array and copy every single element over. Talk about tedious.
And this brilliantly illustrates why mastering recursion is an absolute must-have skill. Why? Well, unlike linear contiguous arrays, other vital data structures, like linked lists and binary trees, have their data scattered all over the place in memory, connected only by nodes. Since these are inherently recursive data structures, it means a lot of the complex problems related to them actually have way simpler recursive solutions compared to iterative ones.
So what do these interview challenges actually look like in practice? Well, you'll be asked to find missing numbers in an array, reverse an array in place, find the middle element of a linked list, or check if a linked list contains a cycle. Maybe you'll need to print duplicate characters from a string, or check if strings are anagrams. Oh, and of course, the ultimate tech interview trope, reversing a singly linked list. Seriously, if I had $1 for every time someone had to reverse a linked list on a whiteboard, I'd probably be funding my own startup by now. But honestly, mastering these just proves you've got those fundamental problem-solving chops.
But here is where our entire narrative arc pivots. Because once you pass that interview and start your day-to-day coding job, the rules completely change. As the official GitHub docs beautifully state, remember that you are in charge, and Copilot is a powerful tool at your service. See, AI doesn't replace that foundational knowledge of arrays and linked lists you just grinded to learn. Instead, it acts as your magic weapon to execute that knowledge at lightning speed.
Section 3. Supercharging with AI.
In the modern era, tools like GitHub Copilot are basically your essential companions for writing code efficiently and securely. But to really harness them, you've got to understand their two main modalities, inline suggestions and Copilot chat. Serve very, very different purposes. Inline suggestions, think of them as your autocomplete on steroids. They're fantastic for generating repetitive code, filling out test-driven development tests, or just writing quick snippets as you type. Copilot chat, on the other hand, is entirely conversational. You use it to generate massive blocks of code or, and this is fascinating, to review your code as a specific persona. You can literally tell Copilot chat, hey, act as a senior C++ developer who cares deeply about readability and just have it audit your entire work.
But here's the thing. Copilot is only ever as good as the instructions you give it. That's why prompt engineering is such a critical modern skill. To get the absolute best results, you need to follow these exact steps. First, break down complex tasks into smaller prompts. Second, be hyper-specific about your exact requirements. And third, provide concrete examples of input data, expected outputs, and implementations. Giving Copilot specific, tightly constrained context is literally the absolute key to getting accurate, secure, and highly functional code suggestions every single time.
Section 4. The Cloud Computing Battlefield.
Now, let's zoom out a bit. You've aced the interview, you've written some brilliant AI-assisted code. Now you have to deploy your newly minted application to the global battlefield of cloud infrastructure. And modern cloud computing architecture truly is a marvel. It seamlessly integrates front-end client infrastructure with deeply secure, highly scalable backend services. The real magic of the cloud here is that it distributes computing resources across multiple geographic regions and availability zones. This is what allows your app to achieve massive fault tolerance, effortlessly scale up during traffic spikes, and remain globally available, all without your company having to invest millions of dollars in clunky physical hardware. Now, what's really interesting about this slide is how the big three cloud providers stack up architecturally, because distinct strategies emerge based on this recent comparative data. AWS is just the market behemoth, right? Boasting a massive ecosystem of over 200 integrated services and 102 availability zones. Azure, however, completely dominates in sheer global reach with 60 regions and a staggering 300 availability zones, making it an absolute powerhouse for integrating on-premises Microsoft hybrid systems. And then there's GCP, Google Cloud Platform. While it has fewer total services, it focuses incredibly heavily on optimization and high-performance routing.
Section 5. Optimizing cost and performance.
Because let's be real, architecture is just the blueprint. Scale requires raw speed. When you're deploying software globally, choosing the right cloud platform isn't just about counting features. In a rigorous 30-day standardized load test across the three platforms, we see that every single millisecond counts for user retention. And here, GCP actually takes the crown for the fastest average response time at just 115 milliseconds, edging out AWS at 120 and Azure at 130. Expanding on those metrics to look at throughput and CPU usage definitively proves GCP's lead in raw throughput too, hitting 1,920 requests per second. However, it's super important to note that AWS maintains highly competitive global performance at 1,850 requests per second and is widely recognized for having the highest security compliance in the entire industry. So it's a tight race, and honestly, the right choice depends heavily on your specific workload. But let's talk about the number that keeps engineering managers awake at night: cost. $4,200. This specific dollar amount represents GCP's incredibly competitive annual cost for these standardized workloads in our case study, coming in lower than both AWS's $4,320 and Azure's $4,440. So the crucial point is really driven home when we look at the 3-year total cost of ownership, or TCO. By utilizing GCP's custom machine types, organizations can fine-tune their resource optimization to an extraordinary degree. This leads to the best long-term total cost of ownership, clocking in at $12,800 over 3 years for this standardized model. That saves valuable budget that can just be reinvested right back into further development.
And wow, that brings us completely full circle. From sweating over whiteboarding and array reversal, to writing an AI-assisted codebase, all the way to deploying it onto a highly optimized, infinitely scalable global cloud infrastructure. This is the true modern developer's arc. The landscape is undeniably complex, but you know what? The tools at your disposal are more powerful than they have ever been. So I leave you with this question to chew on. How will you integrate algorithms, AI assistants, and cloud scale into your next big project? Thanks so much for exploring this journey with me, and I seriously cannot wait to see what you build next.